At the beginning of the existence of the solar system, there were 5 large protoplanets in it. Later 4 of them were formed by Jupiter, Saturn, Uranus, and Neptune. About 3 million years after their birth, the gravity of the first 2 celestial bodies threw the 5th protoplanet out of the orbit of Neptune. It was named X. Today, many astronomers are tirelessly searching for planet X. One can argue ad infinitum and whether it is or not, but one fact not to take away: thanks to these searches they explore the solar system more and find other different, interesting objects. For example, the search for planet X in the solar system led scientists to the discovery of Neptune and Pluto. Thanks to this search, the dwarf planet Sedna was also discovered. In 2003, famous astronomers Mike Brown, David Rabinowitz, Chadwick Trujillo announced the discovery of the largest planetary body in the solar system in recent years. No such objects have been found since the discovery of the planet Pluto. The cosmic body was temporarily given the name 2003 VP12, but soon it was classified as a dwarf planet and the more beautiful name Sedna was given. Today Sedna is the most remote among the significant objects of our system. It belongs to the category of trans-Neptunian objects. Its maximum distance from the Sun is more than 900 astronomical units, which, by the way, is more than 10 billion kilometers. The dimensions of Sedna are quite large, with a diameter of about 1,000 kilometers, which is about half the size of Neptune. Thanks to a series of spectrographic studies carried out by 3 orbiting telescopes, the composition of Sedna was calculated. The surface is dominated by water ice, as well as ices of frozen organic matter. Astrophysicists compare the density of Sedna with the density of ordinary kitchen salt. By the way, organic matter, in the composition of the surface of Sedna, is not a sign of the existence of life on the planet in the past or present, but the presence of organic substances is a necessary factor for its occurrence. In addition, scientists have found that the planet's surface is red, the same as that of Mars. The dye of the planet's surface is tholin, a mixture of decayed organic substances under the influence of ultraviolet radiation. Based on the results of spectral analysis, organic matter, in the form of methane ice and derivatives, makes up 83% of the surface of Sedna, with admixtures of carbon and nitrogen. However, the structure of Sedna also assumes the presence of a large amount of water, up to 70% of the planet's mass. It can be found not only in the form of deep ice, as on the satellites of the gas giants, but also liquid. Radioactive decay processes can sustain an entire ocean of water beneath Sedna's solid crust. Nitrogen on the surface of Sedna can evaporate at the moments of perihelion passage, forming a weak atmosphere, with a density of 1/10,000 Earth's atmosphere. But if Sedna flew closer to the Sun, she could be much denser. Then the methane on the surface evaporated and fell out in the form of snow. Something like this happens on Triton, the satellite of Neptune. But of course, first of all, Sedna is interesting to scientists for its orbital characteristics. Sedna spends 4.5 million days to travel the enormous distance of its orbit, which is a little more than 12,000 years. Thus, the entire path of a man from a monkey, to the present time, would have passed in 166 Sednian years. But there is also a more interesting question. Where did Sedna come from? Many asteroids in the main belt could become spheres and even merge into one planet, but if not for massive Jupiter. His interactions prevented the planet from education, between him and Mars. Moreover, it dispersed part of the matter, which is why the total mass of all asteroids, the main belt, does not exceed 30% of the Earth's mass. Other gas giants like Neptune and Uranus behave in a similar way. It is their effect that could explain the eccentricity, that is, the significant elongation of the orbit of Sedna, but since the closest distance of the planet to the Sun does not fit into the planetary zone, the known objects could not have such an effect on it. Sedna could even pass along the ecliptic, the plane of the orbit of the Earth and other planets. How did Sedna end up in her current position? There are 3 main theories. The first is the presence of a large planet outside the orbit of Neptune. which could scatter the trajectory of Sedna, in other words, the familiar planet X. The second theory says that at the beginning of the formation of the solar system, comets were thrown by giant planets far beyond the Kuiper belt, the hypothetical boundary, the Oort cloud. There they experienced the influence of already external non-solar gravitational forces and fly away even further, but for this they need to move away by at least 100,000 astronomical units. Sedna still falls short. And the most interesting, according to tradition, left for last. Third theory. It assumes the birth of the Sun in a large cluster of stars. There are several confirmations of this. The rapid rendezvous with a massive body suggested by the previous version could not have built an orbit as complex as that of Sedna. Moreover, it fits into one of the concepts of the Oort cloud formation. Astronomers have come to the conclusion that the parameters of the orbit of the planetoid Sedna indicate that our Sun may be part of a binary star system. Binary systems, in principle, are common in our galaxy. Astrophysicists have long been searching for a hypothetical satellite of the Sun, the so-called Nemesis. But about her sometime next time.